right, the 3.1 videos and questions is going to go over specific things of recursive statements for arithmetic sequences. So the first thing we need to talk about is the word recursive. So if you recall from class, recursive means that in order to get the next term, you have to have the previous term. And when we say previous term, we just mean the term before it. Previous term. So for example, if you look at example 1, if I was talking about 15, the previous one would be 5. If I was talking about 25, the previous one would be 15. 35, the previous one would be 25. Now, also, we have to have what we call an arithmetic sequence. And in order to have an arithmetic sequence, you have to add the same number each time. And we call that number each time the common difference. Okay? So I do want to go through the two pieces you need for an arithmetic equation. The first thing you need is your statement. So we have a sub n is equal to a sub n minus 1 plus d. So let's break apart what this actually means. A sub n is your next term. A sub n minus 1 is your previous term. And d is your common difference. The other thing that you have to have is your start statement. So a sub 1 is equal to your starting number. Another thing you may see is the initial term. If you don't have your initial term, you're not going to know where you start. I could give you the first statement and say add 3 every time, but if you start with 5 and I start with 6, our sequences are going to look very different, even though we would be adding the same number each time. So I have two examples here. The first example is 5, 15, 25, 35, ... means it goes on forever. A quick way to determine if it is arithmetic is to do term 2 minus term 1, and that will give you your d value. So in this case, 15 minus 5 gives me 10. Now you need to make sure that it works for every single piece. So from here to here, I added 10. Here to here, I added 10. Here to here, I added 10. So as long as all of those are the same, then you're ready to write your statement. So what you're going to do is you're going to bring down a sub n equals a sub n minus 1. And then what are you doing each time? And make sure, I didn't do a good job there, but make sure when you're writing these are subscripts. So that n is little, and at the bottom, the a sub n minus 1 is little at the bottom, and we're adding 10 each time. This answer would only be half correct because you need to tell me your initial term. So since my initial term, the first number is 5, I say a sub 1 is equal to 5. Now would be a good time to pause the video and try example 2 without me, and then keep playing to see me go over it. Same thing in the next one. If I wanted to find our d value, remember I could do the second term minus the first term, and I recommend that you do this because with negatives it gets a little tricky, and when you're subtracting, a lot of kids forget that that's the same thing as adding a negative. So d would be equal to, you got to make sure it works for every single one, negative 7 minus negative 3, and that's going to give me negative 7 plus 3 is negative 4. So from here to here, I added negative 4. Here to here, I added negative 4. Yes, minus 4 is the same thing, but I want to make sure we know adding negative 4. Adding negative 4. I think I have a few too many adding negative 4s. So then we're ready to write our statement. Bring down a sub n equals a sub n minus 1, bring that down as well. And then you can say plus -4. You could also say -4. Those mean the same thing. Okay, and then a sub 1 is equal to whatever our starting number is. Our starting number was -3. Likewise, if I were to give you this statement, you should be able to find the first 4 terms. I would start with -3, then I would add -4, which would get me to -7. Add -4, which will get me to -11. Add -4, and that would get me to -15. Thanks for watching.